Today, we will again have a product demonstration day for you online. And for those who have been here yesterday, we started with SAM PuttLab. Today, we will dive a little bit more into our studio. We have two sessions which are planned. The first hour will be covered by me. I will explain how we work in the studio. At this time, we will only use SAM 3D, SAM video, and a balance plate. And tomorrow it will be then extended into ball tracking and projection, which is maybe of highest interest to you. But let's do it step by step. At 6 p.m. our time, we have a very, very interesting guest speaker, which is David Orr. He will talk about swing planes and body motion and how this correlates. And this will be very, very interesting for you. So I can just recommend to stay inside. Let me just check if everything is okay. And if there are any problems, please write me a message through the chat. I hope you can hear me. This will again be recorded and you will get a link to view it then offline also. Okay, let me just start with getting into the studio. And if we want to work with the studio, we normally use the studio Dialog, which is controlling all the different technologies of the studio and how they would be started up automatically if you have a specific environment where you want always the same configuration to start up automatically once you plug in your computer. We have SAM 3D, so it can be connected or it can be automatically started, and we can dock it to a specific window or to a specific position in a window, which is very helpful if you don't have screens for all the different applications. For example, if I work with 3D and video, I do a split screen and I dock it right and I dock it left. So I have a pre-positioning of the windows already on my screen, which matches up to what I need to do. We have some video, again, auto start, and I can connect it here. We have Balance Lab, or the Balance Lab software basically, which is also then extended to putting, which again can be connected, auto started. We would be able to connect a platform, which could be a movable platform. At this point, it is not installed. Once it is installed, you could also start it here. We have SAM ball tracking, which is the camera, which can also be started here. And then we would have SAM projection, which is also not installed in my location here. And then certainly SAM PuttLab can also position on some screen at a specific position. So this is your control center of the studio. And if you implement it once to a specific configuration, you can then pop it up exactly in this way all the time. And then there's a different dialog, which is configuration of ball tracking and projection. And this is not important for today. And this is another dialog controlling how you set up projection and ball tracking, which might be more important for tomorrow. Okay, before we go into depth of analyzing the data much more in a 3D and a video environment, let me just start another video which I have prepared for you. I think I need to restart it. Sorry, there was no sound, I think. I apologize. In the
In the SAM Studio, you can activate all the different components. It's a modular system, so we can, for example, only use video and 3D at the same time. To do this, you simply need to activate 3D and video in the Studio control dialog. It will pop up automatically, and now you're ready to go. Everything will be synchronized, will start automatically, will replay automatically, and if you scroll through it, you will always work on the same timeline. Okay, can I please see some more putts from my student? I will start the training mode, activate video. We might need another calibration to be sure that everything is in the right space. We already see the live video down here. Ready to go? Okay. And now, can you please hit a putt? And now the same putt we see on the PuttLab screen will also be displayed on the 3D screen. And synchronously, we will also see the same putt down in the video. So if we now scroll through the video, we see exactly the same slide or the same frame in time. So video shows you down the line some relevant information, for example, for fitting. Now at the same time, you might go into 3D and then look at the putt from any angle. For example, if we stay in this view, we can select it also from the back side, or from the front, or from the top, whatever you want to do. And this data perfectly corresponds certainly to what you see now in PuttLab. So you have very different sources of information, and depending on the aspect you work on, you can select which aspect to show to the student also. Normally, the data is more relevant for the coach because it needs to be understood. For a student, it's much more easy to look at the 3D or the video. So you might use 3D and video to explain certain aspects inside of a putting stroke to your student more visually. For example, you might look from a top view, and at the same time as you look down, you run the film, and you can even look at the ball going to the hole in the lower video. And then you have a lot of different options with regards to different profiles in 3D, showing you putts from different angles combined with different amount of information.
Okay, let me just go a little bit more into depth if we talk about 3D, what 3D can do. This is kind of a core part now of our analysis, that we're able to display data one-to-one, side-by-side, in SAM PuttLab and in 3D. So if I want to start up 3D for a specific data set, I might activate it in the dialog, or I might directly pop up a specific data set, which is, for example, this one here, which we have just seen. And then inside of the data set, I could press the 3D button and the software would automatically start. Now, as we have defined, it starts on the right side. And maybe I do a full screen now, as we maybe wouldn't need to see it full screen, and I need to think I wouldn't need to share now the 3D software so that you see actually what I'm talking about. So if we have a specific putt We can look at it from any angle. We can certainly combine it with other systems here, but let me just start a little bit explaining what we see in 3D and how what the options are in 3D. So let us pop up a specific student, or we might even pop up, which is more important for you to see, maybe a specific player. We might even look at Tiger Woods. I think you heard that he had a very serious accident, so we hope he will recover soon. This is one data set of Tiger Woods from 2003. And now we can look at this putt from different perspectives, and we have different tools now to do that. So we can, in general, have, we can look at different view angles, which would be top view here, which could be from the front, from the back, from left, and from right. These are kind of perspectives, general perspectives, irrespective of what you select elsewhere. You can look at these pre-configured views via a specific direction. At the same time, you can use these predefined profiles, which activate certain aspects of your display, which are hidden here. So for all the different configurations and predefined profiles, which you see here, we have activated specific additional feedback relative to your putt. And this could be up here, launch data at impact. This could be a template. This could be ball trace, which could be on and off. This could be putter path, face angle, impact spot, shaft lines, and swing plane. So this can be configured separately. We might do this afterwards in a normal putt, but this is also already pre-configured in these profiles here. So face angle combines path and face angle. And we can now look at this certainly from any angle. In 3D, we can again look these predefined view angles here, or we might move it around. We might amplify and zoom in and zoom out. So this is all up to you. That's one predefined profile, which is called face angle. Now for impact spot, we see that we have now additionally a mark on the putter, which is reflecting the impact spot. Down here, you have a time bar. And this time bar can be scrolled with a mouse cursor, so you can go to any position. You can use the tab to go through different positions. And then you certainly can also replay it and run it at different speeds. This would be 100% speed. So this is a predefinition that the path would stop, or the putter would stop at impact. 100%, 50%, even slower, 25%, or very slow, could be 10%. This can be freely selected. Maybe we keep it at 50%. We additionally can certainly always scroll through the time by using this time slider down here. And again, if you want to, at impact, see it from different perspectives, you can again just go here and do whatever you want. And then shaft lines is the prolongation of the shaft to a specific pivot, which you can also see in the SAM PuttLab software. We will see this later. Now, why is this important? Let's see for Tiger if something happens up here. So if you just look at this picture in a more general view, you don't see that much. But if you carefully look up here into the pivot, you see there's a specific pivot in the beginning, or the backstroke, which is somewhere up here. In the forward stroke, you see it shifts a little bit to the left of the player, and then the pivot is more down here, or the forward rotation. So you see backstroke seems to be higher in pivot, which is probably more shoulder, and then forward stroke, it moves down, which is potentially more hands. So the radius of this shaft plane decreases significantly between backswing and forward swing. And this is already quite a bit of information. Certainly you can look at all the different angles here. And again, you can use the different options here. Now, launch view is thought a little bit for a fitting process, where at impact, we display the 3D D-plane in a split into horizontal and vertical view. This would be the vertical D-plane, where we see launch angle as a consequence of effective loft and angle of attack. So the putter stays at impact because this is actually where we measure. The red line would correspond to the surface of the putter, which is the effective loft, and the blue line would be the launch angle. And then we would see a red line and a yellow line, which is underneath the blue line. We will see it maybe if we look at it from the top. So basically, these three arrows representing launch, effective loft, and angle of attack are almost exactly at the same angle, so they are superimposed. So you don't really see that here. We have a horizontal view, which is again the D-plane, but now in the horizontal perspective. We have ball direction, which is 0.4 right. We have face angle, which is 0.3 open, and we have path angle, which is 0.8 to the right. So there would be a little bit of a difference between these angles, not very much. So this is thought as a view which can be used for fitting or to control launch conditions. And if you have a player and you are working on, for example, hand position to change the amount of launch angle, or you change ball position to influence angle of attack to the ball, this screen could be used to feed back this information to your student, and you might even replay it, and then at impact it would show you the corresponding data. Then we have templates, and templates correspond to a specific swing plane. They show you the theoretical neutral putting stroke inside of a neutral swing plane, which has a specific incline. This swing plane has 18 degrees of incline. We might amplify it to 21 or 24, or we might go down to 15 or 12. The less incline, the less arc, the less rotation against the target line, the more incline, the more arc, and the more face rotation. Now we see that for Tiger, even at 24, this would not be enough to match up to his putting stroke. So you see there's even more rotation as in the 24 degree template. And we will see in the swing plane and in the putt plane, the Tiger's plane is very, very, very flat for face, because he has a lot of face rotation. So we would need to have another player. For example, we might select, this is Paul Asinger. And now we see that this matches up pretty well. And this is a 3D swing plane. It's not only a plane which you put down onto the ground. The problem is if you would just lie it on the floor and you would look at it from different view angles, you would get a different information. Now this is a swing plane template, which is true for different view angles also, okay? So this is a template which can also be used if the eye is not exactly over the template. The 2D templates which you position down onto the ground are only valid if your eye is exactly over the ball. Otherwise, if you sit sideways, your putter would look different as compared to the swing plane. Now this swing plane would move with your view position, and this can certainly be added to your training environment to look at it on the screen. We might certainly also project it at a later point in time if we talk about projection. And then if it comes to swing plane, this is kind of an interesting topic, and we see here swing plane first, which is corresponding to the path of the player. So this means we do a fit of the path into a rotational movement, and the best fit would end up with this swing plane, and as a consequence you would see that this plane, which is blue, would almost perfectly match up with a path which is yellow. We don't go to the very end, so we cut a little bit at the end and the front. So it's kind of the intermediate section around impact, which is inside of our best fit. Okay, so this is the consequence. So this doesn't mean that this path is perfect for all the swing planes. It's perfect for this specific swing plane because we do a fit. So this blue line and the plane, the corresponding plane, is a fit relative to this path. And what we then see as the best fit for this path is having a radius. It's a center, which is here. We have a radius, we have a direction. If you look at it down the line, this plane has a direction. Then if we look at it sideways, it has a tilt angle. And now for this player, which is Paul Asinger, we see the swing plane tilt is 26.5, so it would be an angle of 64. So the putter would be at about 70, so a little bit more flat as compared as the putter plane, but almost neutral. The radius would be 164 meters, which is a little bit high. So we would see that Paul Asinger is not using too much hands. We will look at this later where this comes from. And then we would look at low point, which is almost at impact. It's just 0.06 meters, which is 6 centimeters up front. So a little bit up front, but not too much. And the direction would be 0.3 left of this swing plane. Coming back to Tiger, looking at Tiger's swing plane. We see that this is completely different. Swing plane points to the right of the target line by 1.3 degrees. Radius is 1.26. So average swing plane for a tour player would be in a range of 1.35, 1.4 meters. This is even a little bit low. The tilt would be 7.2, so it's much steeper than the plane of the putter. In this case, it would be some 83 degrees roughly. Low point is also slightly before impact. Now, if low point is before impact, somewhere here, then you very naturally would have a positive angle of attack to the ball. If low point is at impact, your angle of attack would be 0. If low point is after impact, your angle of attack would be negative. And this is a typical sign of the swing plane of a tour player, that the center, which is the blue dot here, which corresponds to the low point, is in almost all cases slightly before impact, and then this would result in an angle of attack which is positive. If you play cross-handed, left hand low, this center would move slightly to the right, and as a consequence, also the low point would move to the right, and this would reduce angle of attack. So angle of attack for tiger is 3.3 upwards, because low point is upfront of impact. Now, there are even more options in here. There are certainly options for ball tracking, which we show if once we introduce ball tracking tomorrow. What we can do here is we can also use split screens. So we might, for example, compare Tiger Woods to Paul Azinger. And then you have different options how you would do that. You could do this on one screen, and then you see a blue putter and a black putter. And for example, you could play it at the same time. And you would see that Tiger and Paul Azinger are roughly using the same timing, but there is a little bit of a difference in the amount of follow-through. The through stroke for blue, which in this case is Paul Azinger, is longer than Tiger's, but the timing is almost exactly the same. So this could be used, for example, to compare a reference putt stroke at a specific timing to your student's putt stroke. So if you play a putt, it will be replayed in parallel to your reference putt, and then you can look at the differences, which is a very intuitive way of looking at timing, that you see, okay, how much amount of backstroke, what time does it need, how much time for the through stroke, what length of through stroke, what's the ratio. So you might use your reference, which you decide relative to what you think is a good stroke, and then you could replay it to your student, which is very intuitive here. You can have a split screen left and right, which is just the same. On the left side, you see Tiger. On the right side, you see Paul Azinger. And all the options you have are then true for both. You might, for example, introduce the swing plane for both, or you might introduce the shaft lines for both, or you might introduce a template for both. That's true on both sides. And you might do a top-bottom split. Okay. Again, this is true for all the different views. Okay, I hope I didn't miss something. And now if we have SAM PuttLab and SAM Balance Lab, and we will look at this afterwards straight away, synchronized, you can scroll through the putts, and certainly then the reporting in PuttLab and on the different screens would change accordingly. We will just look at this in a second. Okay, maybe I just interrupt here to check if there are any questions from your side. Okay, one question in here. Do you have this information also for different putter styles, mallet or long putters? So we have different putter styles. At this point, we have different colors. We have a blade and we have a mallet center shafted. The problem is that we always need to have the 3D, so we don't have an oversize putter style at this point in time for 3D. But we have a mallet center shafted and a blade which is hosel mounted, and then we can have the blade in silver or we can have the blade in black. This can be selected. Okay. Any more questions at this point? Let me just share my screen a little bit differently. I will share now, not the window, I will share my complete screen so you can see everything which is there. Let me just check if this worked. If I change now to the PuttLab software, you should see the PuttLab software, which is true. And if I now do a split screen of the PuttLab software, let's just try to do it like that. And certainly this option is much more powerful if you have a true multi-monitor system which you are using. So I think it should be at this point, if you use video, 3D and balance and PuttLab, it should be 2 screens, which could be enough, because then you would have, for example, PuttLab on one screen, and then the other screen would be a split by either Balance Lab and video, or Balance Lab and 3D and video and 3D. I will show this later. So if I now select a different putt in the 3D software here, I go to single. Okay, there's only one putt here, sorry. If I would pop up another data set here. And if I go to single, then we have putt 7-7 here, and irrespective of where I change the putt, it would automatically change also on the different softwares. So this means if I'm in a training mode, or if I'm in an analysis mode, and if I switch between different putts, it's all synchronous, and this makes life very easy. Now let's do something more sophisticated. We will add now the video. Maybe we get back to this putt here, and we look at maybe the top view. But now I will add video here. I will start it up here. Video will now dock to the left. And we have 3D, which we have put now to the right. I will just shift it to the right now. And this would be now our putt. And now the data on the left and the right and the data in PuttLab is just the same putt. I'm not sure if you can see this properly, because there might be some overload of these screens. Okay, if I now go to a specific position on the left putt, maybe let's go to impact, then this would all be synchronously scrolled to the same position. I can look at it from the same angle, from behind. Let's just look at the normal view here. And if I scroll through this putt now, everything would move perfectly synchronized. So I can let it run side by side, adding, for example, the swing plane or adding some other information, but I might now look at it also from different perspectives. So the left side would tell me, for example, in the video about what happens, for example, to the hips or to the hands. For example, we would see that the putter, what you see on the right, is going more to the right. So the forearms are a little bit extended to the right. This is what you see here. At the same time, the hip opens to the left. I hope you can see that a little bit. So you can look at the body motion on the left, or details which you might look at in the high-speed video at the same time. On the right side, you can look at it from any angle. So this is the same putt now, and you can look at any aspect you want to see. And this brings in a couple of very interesting options to get your student involved, because he can see himself now on the left at the same time. He sees his putter motion on the right, and you can add specific data on that to make specific aspects of the putting stroke more clear. And so I think this is a very, very powerful tool for teaching and coaching. Okay, so this would be, from my perspective, very simple. And if you think about the amount of hardware you need to invest, so you just need to have a high-speed camera, which might be a Logitech Brio, which is really not too expensive. And then you can use 2 screens, and you already have a very good environment, which is beyond what PuttLab alone is doing. And as I said, PuttLab is thought maybe more for the coach, but this environment might be more used for teaching, coaching, and for your student. Okay, so far, any questions to this point? Let me just check the chat. Not yet. So maybe we prolong this now a little bit into a concept of swing plane, and I have prepared a small video on that. So David Orr will at 6 o'clock talk about this in depth. This topic becomes much more interesting the more data we're able to gather. And I will now show the baseline of what we see in the report. And I will not talk really too much into depth on that, because David will explain this very much into depth from a coach's perspective. And this will be quite interesting. But just to start getting into this topic by showing you what you would see in the reporting of SAM PuttLab.
If we look at the swing planes of our student, and swing planes can be seen in 3D and can be seen in the SAM PuttLab professional report. And we see the average swing plane for path is at 54 degrees only, so this is very flat. And the face swing plane is in average at about 70%, which is neutral. So there is a lot of increased arc in our student's putting stroke. But what is also interesting is that if you look at swing radius or swing plane angle, they vary dramatically between the putts. So swing radius is the point around which you turn your shoulders, your arms, and the putter. And if this is not a stable position, so then this means that you are rather using your arms, or you have problems in keeping this pivot stable by changing your balance, for example. If you also see there are problems in angle, swing plane angle is kind of relative to the arc. This means you are rotating more or less, probably also because your arms are becoming more active. Let us look at 2 different strokes in the single putt mode here. So for example, this is the first putt. It's an extreme flat path plane with 30 degrees only, and there's a very, very huge arc. If you look from behind at this swing plane, we see that is pretty flat. And if we look at the second putt, just the next putt, we see all of a sudden this is almost vertical. So this is kind of the opposite, on the opposite side. So the student here has a problem in defining where the pivot for his swing plane actually is. Path plane again is more neutral, so it's not really the face, it's more the pivot of the path itself. So let me bring our student back onto the putting green and let's look at swing plane. And now I would like him to more feel a pivot, which is roughly the upper half of the spine, which remains stable, so that we see that these two planes start matching up in the data. I will pop up the corresponding report here. Okay, so can you just do it without a ball before, because it is always easier. So try to rotate around a stable spine. Don't try to move the head. Okay, you see this was already quite good. Can you do one more? So actually he is still moving the head, and he might more feel that the rotators rotate around the spine. So the head is stable, so the head doesn't move at all. You just rotate the shoulders around the head. Okay, that's okay, just a little bit smaller stroke. Okay, this was good. And this is much more close and much more neutral. Now if we bring in a ball, and at the same time we look at swing radius and swing plane here, if this is stable and not fluctuating too much inside of the impact zone. Okay, he was again having a very flat swing plane, so there's a lot of arc. Okay, just reduce the amount of stroke a little bit and try to more move only the arms and keep your upper trunk stable. Okay, one without a ball. So this is much more easy for him. So it's a problem of the ball actually. And I might help him by giving him a sensory position here. So don't lose this contact. Okay. And now you see, this is where it should be. So you need to find out how you can be more stable. One more. I give you again a reference point. Okay, and this can also be used for fitting, because the red, which is face, corresponds to the head design with regards to toe hang, and this would be more for the kind of arc or the type of path plane. The more flat, the more you would need a blade, and the more upright, the more you would need a square putter head. So we can also use this in fitting. And at the same time, we can look at the high-speed video, and both will run in parallel. So this would be a system which could be used to not only correct setup, but to also correct your swing plane and the different planes for face and path.
Okay, that's already a preview of what David Orr will explain with much more expertise, to be honest, than I do, because this is not really the field where I come from. And I learned a lot by David, but he will go really into depth of that just in 15 minutes. There was a question in between, when SAM PuttLab calculates the fit swing plane, what portion of the overall stroke is used to calculate it? Well, basically, we use a fit which is matching up basically all the data points you see, but we ignore a little bit the left and the right end. But if you look at, for example, our PuttLab report, you will see that we also have a dynamic, for example, radius, a dynamic angle and direction and so on. So we are not only able to show this angle at impact, we are also showing these angles throughout your complete putt stroke. This is not yet implemented in 3D. We will come up with this shortly, and we will also show the face plane in 3D shortly, but this would be a dynamic plane, probably where you can go through. So if we do a fit, this fit is normally in a range of about 20 centimeters or 8 inches. And once you get to the very end, we just stop the fit, because if you are at the end of a stroke, there is no more fit possible. So it's kind of the intermediate section, which roughly match to the plus minus 4 inches of our impact zone. At the same time, we would then shift this back and forth. So we would have the swing plane angle in the center, which normally is at the low point. This is direction of the swing plane. But then if you scroll back or forth, the direction of the swing plane could also change. Okay, the last part is talking about balance. As I said, I don't go deeper into this because David would explain all this to you, which is much more expertise. So let me just go to the last thing here, which is including now balance. And if we talk about balance, we might use either the Balance Lab itself, which is our product, or we might use, for example, Body Track, which is a mat which can be integrated, which doesn't really make a difference. For putting, Body Track is also okay.
The last ingredient to our putt studio is balance. We can use our SAM Balance Lab, which is a solid plate, but we can also use mats, pressure mats, and this can be just positioned on the turf, and it is again synchronized with video, with 3D, and with all the data. So we start a measurement or a training session, we activate Balance Lab software, and everything is loading up. Okay, Christian, can you come again? And now you already see live data here. So can you just stay centered? We see now the live data from the ground reaction forces. This is the center on the left foot. This is the center on the right foot. We see the angle relative to the target. So the right foot is slightly open. The left foot is a little bit open. We see the center from this balance graph. This is live data of the downforce, activation of the forces in the vertical. And here we see in this profile, left foot, right foot, front, back, and the center. And if the red dot is in the center, then you are centered front, back, and left, right at the same time. And all the time, this comes into front or back or left or right. We know that he is not in balance. In putting, it is just the opposite of full swing. In full swing, you want to activate ground reaction forces to maximize force and energy. In putting, you want to stabilize, to stay as centered as possible, to not allow the swing plane to get off the neutral plane, and you don't want to become way too much front or back, because sway would definitely have an influence, for example, on impact spot. So we can now let him just hit a putt and look at the result. First, we start with the calibration. I start the calibration with a countdown. We have live video here, and we have 3D data down here, all synchronized. Okay, now we are ready to go. Okay, now looking at the replay, we see that he started very much coming from the heels. I can also go through the data with this slider. So top of backswing, he is almost back to neutral, but he started very much at the heels. So maybe he is standing a little bit too close to the ball, so leaning backwards would help him to just aim the putter correctly. We need to check where this comes from, but actually at top of backswing he's back to neutral, and then in the forward swing it falls again back to the heels. And if we look at the corresponding path, let's check what we see. Well, a little bit inside through impact. So hitting it slightly at the toe, which is not too much, 4 millimeters, but this can certainly be cured if he stays more centered from the very beginning. So if you play now the next putt, please, and try to put the weight a little bit more to the center. In particular, we don't want the left side to become weak. So we would, for example, say, try to put more pressure to the left center and front. Okay, very good. So the next part, he tries to put more weight to the center of the left foot and to the front of the left foot. Try to not sway. Okay, let's check. Now he's much more to the front. This was maybe even a little bit overdone, but looking at the sweet spot, this is now more centered. We also might maybe adopt a little bit a wider stance to be more solid, so maybe one last putt with a wider stance. Again, centered to the left and right foot. Okay, very nice. Now, already on the opposite side, slightly at the heel. So we can just go through the different data, checking balance again, which is one, balance statical wise, but then also dynamical wise. The center of pressure, in this case, very much centered, not too much sway. And so by doing this, you help your student to be much more stable and to have a much more solid swing plane.
Okay, this was about balance in putting. I think this is not yet a topic which is really covered. Still, it is an important topic. We know that there is an interdependency between balance and specific aspects of your putt, in particular if it comes to path, in particular if it comes to impact spot, and maybe if it comes to orientation. And this can be seen certainly in your data. So let me just pop up again this session to show you again how this would look alike if you analyze it afterwards. So this is my data set, which I can just show in a second. I just need to open it in the background so that you're able to see it. Just a second. Okay, let me share the screen. I hope this works now. So you should see now on the left side Balance Lab. Then we see on the right side the 3D, and this is PuttLab. And let me just look at, for example, the first putt in this set. It would be this one, and we look at maybe the path in the top view. And if we now look at 3D and path relative to this data, in Balance Lab, it would be the first putt. And what you can see here, if you look very carefully, that what we've seen before, he's falling to the front and then falling back to the inside in the follow through. So this is centered, it's coming from the back, then this is centered and then coming back to the inside, what you see down here. And accordingly, the putter moves very much to the inside. If we look at the second putt, then we see that the path is much more straight because now the center of the weight is more staying also in the center. So the direct correlation between your center of weight or center of pressure and the motion of your COP, which is the center of pressure. Now this was maybe a little bit too front, but at least he stays front. And then for the third putt, we would see that this is now again front, but then falling back to the inside in the follow through. Okay, no, not for this putt. I thought it was another putt. So he's staying to the front, a little bit falling inside after the finish, but the finish position is still very much front. And this is now overdone. And that's an inverted arc because he's even moving outside in his stroke. So this interdependency can perfectly be monitored by this setup. And this is one way of looking at a putting stroke from a different perspective, which also offers a lot of different options. I know this is not the normal use case out there, but coming up with Studio, this is a very smart option to add a Balance Lab or a pressure mat like Body Track. And again, this will be synchronized. You will have the video also synchronized, and you can replay everything at the same time.